You're standing under a star-strewn sky, the kind that makes your neck ache from craning upward, lost in the vastness. Billions of stars twinkle, each a potential home for life. Yet the universe remains eerily silent. No signals, no visitors, no cosmic postcards. Why? This question lies at the heart of the Fermi Paradox, named after physicist Enrico Fermi, who, over a casual lunch in 1950, asked his colleagues, "Where is everybody?" It's a question that haunts scientists, philosophers, and stargazers like you. If the universe is teeming with planets, many older than Earth, shouldn't we have heard from someone by now? Let's dive into this cosmic mystery, unravel why the universe seems so quiet, and ask, are we looking in the wrong places? Before we go further, hit pause and think. What's your take on why we haven't found aliens yet? Drop it in the comments, and let's see if this video changes your mind. Picture yourself gazing at the Milky Way, a glowing ribbon of light stretching across the night. Each pinprick of light is a star, and around many of those stars orbit planets, potentially billions, in our galaxy alone. In 1961, astronomer Frank Drake crafted an equation to estimate the odds of communicative alien civilizations. His Drake equation, a blend of factors like the number of stars, planets, and the likelihood of life evolving, suggests there could be thousands of intelligent civilizations out there. Even conservative estimates hint at dozens. So you wonder, if the numbers add up, why haven't we picked up their signals? Are they all just shy? Or is something else at play? Let's set the stage. The universe is old, 13.8 billion years young. That's plenty of time for life to emerge, evolve, and build interstellar empires. Earth, by comparison, is a relative newbie at 4.5 billion years. If intelligent life exists, some civilizations could be millions, even billions of years ahead of us. Imagine what humans might achieve in a million years. Space stations, Dyson spheres, or tech we can't even dream of. Now scale that up. Advanced aliens might have colonized entire star systems. Yet when you look up, there's no cosmic neon sign saying, "We're here." This silence feels like walking into a party where everyone's hiding in the dark. Are they avoiding us? Or are we missing the invite? Here's a quirky tidbit to chew on. In 1974, we sent a message into space from the Arecibo radio telescope in Puerto Rico. It was a binary coded burst of data aimed at a star cluster 25,000 light-years away, detailing human DNA, our solar system, and a stick-figure human. It's like sending a cosmic text with no reply expected for 50,000 years. Talk about a long-distance pen pal. But here's the kicker. We've only been broadcasting for a century, a blink in cosmic time. If aliens are out there, they might not even know we're here yet. Now, let's stir the pot with a scholarly debate. Is the Fermi Paradox a problem of scale or a hint at something deeper? Some argue it's a matter of distance. Space is just too vast. Light travels fast, but even at 186,000 miles per second, a signal from a distant galaxy could take millions of years to reach us. Others say the paradox points to a flaw in our assumptions about life itself. Maybe intelligent life is rarer than we think, or maybe it's common but short-lived. You start to wonder, are we shouting into a void? Or are we tuning into the wrong channel? Feel the weight of that thought. You're on a tiny blue dot, spinning through a galaxy that's just one of billions. The sheer scale of the cosmos can make you feel small, yet it's thrilling. Every star you see could be someone's sun, their home. But the silence persists. Maybe aliens don't use radio waves. Or maybe they're so advanced, their tech is invisible to us, like trying to spot a Wi-Fi signal with a telegraph. Or, here's a wild idea. What if they're watching us right now, debating whether we're worth contacting? That thought sends a shiver down your spine, doesn't it? Let's toss in a light jab at ourselves. Humanity's been acting like the universe's loudest neighbor, blasting radio waves and reality TV into space. If aliens are out there, they might be ignoring us because our cosmic playlist is just too embarrassing. Imagine them hearing our old sitcom laugh tracks and thinking, "Nope, not ready for these guys." But seriously, our search has been narrow. We've focused on radio signals and visible signs of technology. But what if aliens communicate through means we haven't imagined, like quantum entanglement or gravitational waves? History gives us context. In the 1950s, when Fermi posed his question, the search for extraterrestrial intelligence was just a spark. Scientists like Fermi, a key figure in the Manhattan Project, brought a physicist's rigor to the question of alien life. His paradox wasn't a dismissal, but a challenge to think bigger. Today we've got telescopes scanning for biosignatures, chemical hints of life, and exoplanets by the thousands. Yet the silence persists, pushing you to question, are we alone, or are we just not listening right? Here's a modern twist. In 2023, a viral moment swept social media when a supposed alien sighting turned out to be a prank with drones. It's a reminder that our fascination with aliens often outpaces the evidence. But that fascination drives us. You're part of a generation that's closer than ever to answering Fermi's question, with tools like the James Webb Space Telescope peering deeper into the cosmos. Still, the paradox lingers like a cosmic cliffhanger. Are we looking in the wrong places? Or is the answer something we're not ready to face? As you ponder, imagine standing on a cliff at night, the stars above whispering possibilities. The Fermi Paradox isn't just a scientific puzzle. It's a mirror reflecting our hopes and fears. Are we alone in this vast universe? Or are we just missing the signals? Maybe the answer lies in rethinking what life means or exploring beyond our current tech. For now, let's keep looking up, wondering, and commenting. Because the universe might be silent, but your curiosity doesn't have to be. What's your theory on the silence? Share it below, and let's unravel this mystery together. You're standing on the edge of a vast cosmic ocean, your eyes scanning the horizon for any sign of life. For decades, humanity has been doing just that, reaching out, listening, hoping to catch a whisper from the stars. The quest to find extraterrestrial intelligence has driven scientists to build massive telescopes, send signals into the void, and dream of contact. But how did we start this galactic search, and why haven't we found anything yet? Let's journey through the early efforts to connect with alien civilizations, from clunky radio experiments to cutting-edge tech, and ask, are we even using the right tools for the job? Imagine the 1960s, a time when bell-bottoms were cool and humanity was just dipping its toes into space exploration. The idea of finding aliens wasn't science fiction anymore. It was a serious pursuit. In 1960, Frank Drake, the same guy behind the Drake equation, kicked things off with Project Ozma. He pointed a radio telescope in West Virginia at two nearby stars, Tau Ceti and Epsilon Eridani, hoping to catch an alien broadcast. Picture him hunched over equipment, listening to static like a cosmic DJ waiting for a hit song. Spoiler, he heard nothing but silence. But that silence sparked a movement. You can almost feel the excitement of those early days, the thrill of tuning into the universe's radio station for the first time. Now, fast forward to your world today. You've got apps that let you stargaze from your phone. But back then, scientists were working with tech that seems ancient now. Radio telescopes were the big bet, giant dishes scooping up faint signals from space. Why radio? It's simple. Radio waves travel far, pierce through cosmic dust, and don't need much energy to send or receive. They're like the universe's text messages. But here's a chuckle-worthy thought. What if aliens think radio is as outdated as carrier pigeons? Maybe they're streaming their messages on some intergalactic version of Wi-Fi, and we're still checking our cosmic inbox for snail mail. Let's ground this in history. In 1977, a strange signal gave scientists a jolt. Astronomer Jerry Eman was reviewing data from the Big Ear telescope when he spotted a 72-second burst of radio waves so unusual he circled it in red ink and wrote, "Wow," next to it. The wow signal, as it's now called, was strong, narrow, and matched what we'd expect from an alien broadcast. For a moment, it felt like we'd caught the universe winking at us. But here's the catch. We've never heard it again. You can imagine Amon's mix of awe and frustration, staring at that printout, wondering if it was a one-hit wonder from ET or just cosmic noise. Here's a quirky detail to spice things up. In the 1980s, some scientists got creative and sent a mixtape of Earth's greatest hits into space. The Voyager, Golden Records, attached to the Voyager probes, carried sounds of whales, Beethoven, and even Chuck Berry's Johnny B. Good. If aliens ever find it, they might think we're a planet of rock and roll whales. But it shows how seriously we took the idea of introducing ourselves. Those records are still out there, drifting beyond our solar system, a cosmic message in a bottle. Now, let's toss in a scholarly debate. Are we too focused on radio signals? Some argue we've put all our eggs in one basket, assuming aliens think like us and use technology we understand. Others say radio is still our best shot because it's universal. Physics works the same everywhere, right? But what if aliens communicate with lasers, neutrinos, or something we haven't even discovered? You start to feel the weight of that question. It's like trying to call someone on a landline when they're using a quantum communicator. Maybe our tools are fine, but we're dialing the wrong number. Picture yourself at the controls of a modern radio telescope, like the Arecibo Observatory before it crumbled or the sleek new arrays in the Atacama Desert. These dishes are massive, some bigger than football fields, humming with the promise of discovery. You're not just listening for a hello, but scanning for patterns. Anything that stands out against the universe's background static. It's a sensory overload. The faint hum of electronics, the cool night air, the stars above mocking you with their silence. Yet every scan feels like a gamble, a roll of the cosmic dice. Let's add a modern spin. Today, projects like SETI at Home let you join the search from your laptop, crunching data alongside millions of others. It's like crowdsourcing the hunt for aliens. Meanwhile, telescopes like the Allen Telescope Array scan thousands of stars at once, powered by tech that would have blown Frank Drake's mind. But the silence persists, and you can't help but wonder, are we shouting into a void? Or are aliens just really good at playing hide and seek? Here's a light jab to keep things fun. Maybe aliens did pick up our signals but decided we're not worth the call. Imagine them hearing our radio broadcasts, game shows, Antad's political rants, and thinking, yeah, let's wait till they figure out world peace first. It's a humbling thought. Our early efforts assumed aliens would be chatty, broadcasting their existence like cosmic influencers. But what if they're quiet, secretive, or just not into long-distance relationships? The sensory details hit hard. Imagine standing in the control room of a telescope, the screens glowing with data, your heart racing as you scan for anomalies. Every blip could be the moment, the one that changes everything. But the reality is grueling. Years of listening, analyzing, and finding nothing can wear you down. Yet, the hope persists. You're part of a species that refuses to give up, driven by the same curiosity that made us climb mountains and cross oceans. Those early efforts laid the groundwork, but they also showed how much we don't know. Project Ozma and the WOW signal were just the start, a proof of concept that we could listen to the stars. Now, with better tech and bigger dreams, you're part of a generation pushing the boundaries further. Are we looking in the wrong places? Maybe. But every signal we check, every star we scan, brings us closer to answering Fermi's question. So, keep your eyes on the skies and your comments ready. What's the one tool you think we need to finally hear from ET? You're tuning a cosmic radio, twisting the dial through an endless sea of static, hoping to catch a faint hello from the stars. Radio signals have been humanity's go-to for reaching out to extraterrestrial life, our best bet for a universal language that can cross the vast gulfs of space. But what if we're stuck on the wrong frequency, shouting into a void that doesn't answer back? Let's dive into the world of radio waves, how we use them, why they matter, and whether they're really the key to breaking the universe's silence. Could aliens be broadcasting on a channel we haven't even thought to check? Picture yourself in a dimly lit control room, surrounded by humming equipment and glowing screens. Outside, a massive radio telescope looms, its dish pointed at a distant star system, patiently collecting whispers from the cosmos. Radio waves are special. They travel at the speed of light, slice through interstellar dust, and don't fade easily over cosmic distances. That's why back in the 1960s, scientists like Frank Drake bet on them as the best way to eavesdrop on alien civilizations. It's like choosing the most reliable messenger in a galaxy-sized game of telephone. But here's a playful jab. What if aliens think radio is so last millennium, like us sending smoke signals to someone with a smartphone? Let's ground this in history. In 1974, humanity didn't just listen, we shouted. Scientists at the Arecibo Observatory in Puerto Rico beamed a 3-minute message toward the globular cluster M13, 25,000 light-years away. This Arecibo message, encoded in binary, included a pixelated human figure, our DNA, and Earth's address in the solar system. Imagine crafting a cosmic postcard, knowing it won't get a reply for 50,000 years. It was a bold move, a declaration of "we're here." But the silence that followed makes you wonder, did the message get lost in space? Or are aliens just not checking their voicemail? Here's a quirky fact to lighten the mood. The Arecibo message wasn't our only attempt to say hi. In 2008, we broadcast a Beatles song across the universe toward the star Polaris. If aliens ever pick it up, they might think we're a planet obsessed with catchy tunes. But it shows how we've used radio, not just to listen, but to announce our presence, hoping someone's out there tuning in. The question is, are they? Or are we like a lone radio station broadcasting in a desert? Now, let's spark a scholarly debate. Are radio waves the universal standard for communication? Or are we limiting ourselves by assuming aliens think like us? Some scientists argue radio is a safe bet because it's based on fundamental physics. Any advanced civilization would likely discover and use electromagnetic waves. Others counter that we're being anthropocentric, expecting aliens to mirror our tech. What if they use laser pulses, gravitational waves, or even exotic particles like neutrinos? You start to feel the uncertainty, like searching for a friend in a crowd, but not knowing what they look like. The sensory details pull you in. Imagine standing under the giant dish of a radio telescope at night, the air cool and crisp, the faint buzz of electronics filling the silence. Each signal it captures is a story. A pulsar's rhythmic pulse, a star's faint glow, or maybe, just maybe, an alien broadcast. You're not just listening. You're sifting through the universe's noise, hunting for a pattern that screams intelligence. It's thrilling but exhausting, like searching for a needle in a cosmic haystack. Let's add a modern twist. Today's radio telescopes, like the Square Kilometre Array in South Africa and Australia, are game changers. They're sensitive enough to detect a signal as faint as a cell phone call from halfway across the galaxy. You're part of a world where AI helps analyze petabytes of data, scanning for anomalies faster than any human could. Yet, even with this tech, the silence persists. It's like upgrading from a walkie-talkie to a supercomputer and still getting no reply. Are we missing something obvious? Or is the universe just not ready to talk? Here's a light-hearted poke to keep things lively. Maybe aliens are picking up our signals, but find them boring. Imagine them intercepting our radio waves, infomercials, soap operas, and all, and thinking, these humans need better content before we chat. Jokes aside, our focus on radio assumes aliens want to be found. What if they're deliberately quiet, hiding their signals to avoid detection? Or what if their tech is so advanced, it's invisible to our dishes, like trying to spot a stealth jet with binoculars? The challenge of radio searches hits hard. You're not just fighting distance. Light takes years, even millennia, to cross the galaxy. You're also battling noise. The universe is loud, filled with natural radio sources like pulsars and cosmic microwave background radiation. Sorting out an alien signal from this chaos is like hearing a whisper in a rock concert. And then there's time. We've only been listening for a few decades. A fleeting moment compared to the universe's 13.8 billion years. Maybe aliens sent us a message a million years ago, and we missed it by a cosmic mile. Our radio efforts are a testament to human curiosity. From Project Ozma's humble beginnings to today's global networks of telescopes, we've poured heart and soul into listening. You can feel the weight of that dedication. The late nights, the endless data, the hope that keeps scientists going. But the silence forces a question. Are radio waves the wrong tool? Or are we just not patient enough? Maybe the answer lies in expanding our search, looking for optical signals, megastructures, or even signs of alien tech we can't yet imagine. For now, keep your cosmic radio tuned and your comments ready. What's the one signal you'd send to aliens to get their attention? You're staring into the abyss of space, picturing alien life. But what if it's nothing like the little green creatures in movies? What if life out there defies every rule we've written about biology? The search for extraterrestrial intelligence often assumes aliens are somewhat like us. Carbon-based, water-dependent, maybe even chatting over cosmic coffee. But the universe is vast, weird, and full of surprises. Let's dive into the mind-bending possibility that alien life might be so strange, so unlike anything we know, that we're overlooking it entirely. Could the silence of the universe mean we're searching for the wrong kind of life? Imagine a planet where the air shimmers with a metallic sheen. And instead of water, liquid methane flows in rivers under a sky lit by a faint red dwarf star. You're standing there, your boots sinking into a surface that pulses faintly, as if alive. This isn't science fiction. It's a glimpse into the kinds of worlds we're now discovering. Exoplanets come in flavors we never imagined. Scorching hot Jupiters, icy super-Earths, or worlds orbiting stars so dim they'd feel like eternal twilight. Life on these planets might not need water or carbon. It could thrive on silicon, breathe ammonia, or exist as plasma clouds in a star's corona. The sensory overload hits you, a universe where life doesn't play by Earth's rules. Let's ground this in history. In the 1970s, when NASA's Viking landers touched down on Mars, they searched for life using Earth-centric assumptions, looking for microbes that metabolize like ours. They scooped Martian soil, tested for chemical reactions, and found nothing conclusive. But what if Martian life wasn't microbial at all? What if it was something we couldn't even test for? You can almost feel the frustration of those scientists, staring at data from a red, dusty world, wondering if they missed the obvious. That lesson still shapes how we think about alien life today. Here's a quirky tidbit to spark your imagination. Some scientists propose life could exist inside neutron stars, where extreme gravity and magnetic fields might create self-replicating structures from nuclear matter. It's wild, right? Picture a creature made not of cells, but of vibrating quarks, living in a place where a teaspoon of matter weighs as much as a mountain. It's the kind of idea that makes you question everything you thought you knew about life. Maybe we're not hearing from aliens because they're not on planets at all. They're in places we haven't thought to look. Now, let's stir a scholarly debate. Are we too Earth-centric in our search for life? The rare Earth hypothesis argues that life like ours, complex, intelligent, technological, needs very specific conditions: a stable star, a rocky planet, liquid water, and a dash of luck. But others challenge this, suggesting life could adapt to extreme environments we deem inhospitable. Think of Earth's own extremophiles, microbes thriving in boiling vents or Antarctic ice. If life here can be so resilient, why assume aliens need our kind of planet? You start to wonder, are we ignoring whole categories of life because they don't fit our mold? Let's add a modern twist. In 2024, the James Webb Space Telescope detected strange chemical signatures in the atmosphere of exoplanet K2-18b, a world 120 light-years away. Scientists found hints of dimethyl sulfide, a molecule produced by life on Earth. The internet buzzed with excitement. Could this be a biosignature? But here's the catch. It might just be a chemical quirk, not life at all. You feel the roller coaster of hope and skepticism, a reminder that our tools are powerful, but our assumptions might be holding us back. We're still learning what life could mean in a cosmic context. Here's a lighthearted jab to keep things fun. Maybe aliens are out there, but they're laughing at our obsession with water. Imagine them floating in a methane ocean, sipping a cocktail of liquid nitrogen, thinking, these humans and their H2O fetish. It's a humbling thought. Our search for life has been shaped by what we know: carbon, water, DNA. But the universe doesn't care about our biases. Maybe aliens are energy beings, or crystalline structures that think through vibrations, or even clouds of gas that communicate via magnetic pulses. The sensory details pull you deeper. Imagine peering through a telescope's data, your eyes tracing spectral lines that hint at alien atmospheres. The room is quiet except for the soft hum of computers, but your pulse quickens. Each line is a clue, a possible signature of life, or just another false alarm. The universe feels alive with possibility, yet maddeningly elusive. You're not just searching for life, you're redefining what it could be, pushing the boundaries of biology itself. This idea of strange life challenges everything. If aliens don't need water, planets, or even bodies, our search methods, radio waves, biosignatures, might be missing the mark. Picture a civilization of sentient plasma, living in the corona of a star, communicating through bursts of light we mistake for stellar flares. Or imagine life that exists as information, encoded in quantum states across a nebula. These ideas stretch your mind to its limits, making the Fermi Paradox feel less like a puzzle and more like a wake-up call. Are we looking for life in the wrong places because we're looking for the wrong kind of life? The search continues, fueled by curiosity and a touch of audacity. You're part of a species that's only just begun to explore the cosmic zoo. From Viking's Martian scoops to Webb's distant scans, we're learning to think bigger, weirder, bolder, Maybe the silence isn't silence at all, just a language we haven't learned to hear. So, what's your take? If alien life is nothing like us, what should we be looking for? Drop your wildest ideas in the comments, and let's keep reimagining the universe together. You're standing on the edge of a cosmic cliff, peering into the vast unknown, wondering why the universe feels so empty. What if there's an invisible barrier, a cosmic gatekeeper, stopping civilizations from reaching the stars? The Great Filter hypothesis suggests that some catastrophic hurdle, prevents life from advancing to the point of interstellar communication. It's a chilling idea that could explain the silence of the universe. Let's dive into this daunting concept, explore what this filter might be, and ask, can humanity make it through? Or are we already on the wrong side? Imagine a galaxy bustling with potential, where life sparks on countless worlds. You see planets teeming with microbes, some evolving into complex creatures, a few even building cities. But then, something stops them cold. The Great Filter, proposed by economist Robin Hanson in 1998, argues that at some point in the journey from simple life to galaxy-spanning civilizations, there's a step so hard that almost no one makes it. It's like a cosmic video game level where the difficulty spikes and most players quit. You feel the weight of this idea, a mix of dread and curiosity, as you wonder where this filter lies and whether we've passed it. Let's anchor this in history. In the 1980s, Carl Sagan, the rock star of science communication, popularized the idea that nuclear war could wipe out advanced civilizations. His work on nuclear winter showed how a single misstep, say a global conflict, could plunge a planet into darkness, starving its inhabitants. You can picture the eerie quiet of a post-apocalyptic Earth, cities crumbling under a sky choked with ash. Sagan's warning feels like a clue. Maybe the Great Filter is self-destruction. An intelligent species keep pressing the reset button before they can reach the stars. Here's a quirky detail to lighten the mood. Some scientists speculate the filter could be something as mundane as bad chemistry. Imagine a planet where life gets stuck because the atmosphere lacks a key element, like phosphorus, stalling evolution at the microbial stage. It's like the universe saying, sorry, you didn't unlock the right ingredients for the next level. This odd possibility reminds you that the filter doesn't need to be dramatic. It could be a subtle, biochemical roadblock we'd never suspect. Now, let's spark a scholarly debate. Where does the Great Filter lie? Behind us or ahead? Some argue we've already passed it, that the leap from simple cells to complex life was the hard part, taking billions of years on Earth. Others warn the filter is in our future, maybe in the form of climate collapse, AI gone rogue, or cosmic disasters like gamma-ray bursts. You feel the stakes of this question. If the filter is ahead, every choice we make, every technological leap, every global crisis, could determine whether we join the cosmic club or fade into silence. Picture the sensory details. You're standing in a futuristic city, skyscrapers glowing under a double moon, but a faint unease lingers. The air hums with the buzz of drones. Yet you know one wrong move, say a mishandled superweapon or runaway algorithm, could end it all. The universe doesn't care about your ambitions. It's indifferent, vast, and patient. The Great Filter feels like a shadow, always there, waiting for a civilization to trip. It's a sobering thought. But it also lights a fire under you to keep pushing forward. Let's add a modern spin. In 2025, debates about AI safety and climate change dominate headlines. You see scientists and policymakers scrambling to address risks like superintelligent machines, outpacing human control, or ecosystems collapsing under rising temperatures. These challenges feel like echoes of the Great Filter, real-time tests of our ability to survive our own ingenuity. Social media buzzes with memes about doom-scrolling the apocalypse. But behind the humor lies a truth. We're at a crossroads, and the universe is watching. Or maybe it isn't. Here's a light-hearted jab to keep things lively. Maybe the Great Filter is just bureaucracy. Imagine aliens building a galaxy-spanning empire, only to get bogged down in endless paperwork and zoning laws for their Dyson sphere. Sorry, your megastructure permit is denied. It's a silly thought, but it underscores a serious point. Civilizations might fail not from cataclysms, but from internal flaws, greed, division, or just plain bad decisions. The Great Filter forces you to rethink the Fermi Paradox. If most civilizations hit this wall, the silence makes sense. Maybe life is common, but intelligent life that lasts is rare. Picture a universe littered with the ruins of failed experiments. Planets with fossilized cities, silent radio towers, or abandoned megastructures. You can almost hear the echo of their stories, lost to time. But then you think of Earth. We've survived ice ages, asteroids, and our own early mistakes. Could we be the exception, or are we just not at the filter yet? This hypothesis isn't just about aliens. It's about us. You're part of a species teetering on the edge of greatness or oblivion. Every step forward, from renewable energy to space exploration, feels like a defiance of the filter. But the risks are real. Climate change could choke our planet. AI could outsmart us in ways we can't predict. Or a cosmic fluke could reset the board. The Great Filter challenges you to think bigger, to act wiser, to prove we can beat the odds. So, what's your take? Is the filter behind us, ahead of us, or something we can overcome? Drop your thoughts in the comments, and let's figure out how to keep humanity in the game. You're gazing at a star-filled sky, imagining alien civilizations building structures so vast they dwarf entire planets. If advanced aliens exist, they might not just send radio signals. They could reshape stars, harness black holes, or construct megastructures that scream, "We're here!" The search for extraterrestrial intelligence includes hunting for these cosmic engineering feats. Yet we've seen nothing. Are we missing the signs of alien technology? Or are we looking for the wrong kinds of monuments? Let's explore the wild possibilities of cosmic engineering, and why the universe's silence might mean we need to rethink what we're searching for. Picture yourself orbiting a distant star, its light glinting off a colossal structure. A Dyson sphere, a shell of solar panels encircling the star to capture its energy. The air in your imaginary spacecraft feels electric with possibility. This isn't just sci-fi. It's a concept from physicist Freeman Dyson, who in 1960 suggested advanced civilizations might build such megastructures to power their societies. You can almost see it. A star dimmed by a lattice of panels, its light flickering in patterns that betray artificial design. But when we scan the skies, we find no such structures. The silence feels heavier now, like a city skyline with no lights. Let's anchor this in history. In the 1960s, Soviet astronomer Nikolai Kardashev proposed a scale to classify civilizations based on their energy use. A Type 1 civilization harnesses its planet's resources, like us. Type 2 masters its star's energy. Think Dyson spheres. Type 3 controls an entire galaxy's worth of power. Earth's barely a Type 0.7, still figuring out solar panels. Kardashev's scale gives you a sense of scale and ambition. Alien civilizations millions of years ahead could be Type 2 or 3, reshaping entire star systems. You feel a mix of awe and insignificance, wondering why we haven't spotted their cosmic handiwork. Here's a quirky tidbit to spark a smile. In 2015, astronomers studying the star KIC 8462852, nicknamed Tabby's star, noticed its light dimming in weird, irregular patterns. For a hot minute, some speculated it could be an alien megastructure, like a partially built Dyson sphere. Social media went wild with alien megastructure memes, but the truth was likely dust clouds or comets. Still, it's a reminder of how tantalizing these searches are. You're on the edge of your seat, hoping for a glimpse of something extraordinary. Now, let's stir a scholarly debate. Are we too focused on megastructures as signs of alien tech? Some argue that Dyson spheres or similar constructs are logical for energy-hungry civilizations, and we should see them with our telescopes. Others say advanced aliens might use tech we can't detect, nanotech, quantum computers, or energy sources that don't leave a visible footprint. You start to question, are we looking for billboards when aliens are writing in invisible ink? Maybe their tech is so efficient, it blends into the cosmic background, leaving us clueless. The sensory details pull you in. Imagine peering through a telescope's data, your eyes tracing light curves from distant stars. The room is quiet, save for the soft hum of computers analyzing petabytes of information. You're hunting for anomalies. Stars that flicker unnaturally, infrared signatures of waste heat, or shadows of structures crossing distant worlds. Each data point is a story, a chance to find a civilization's fingerprint. But the universe is vast, and the search feels like combing a beach for a single unique grain of sand. Let's add a modern twist. In 2025, projects like the Breakthrough Listen initiative are scanning millions of stars for signs of technology, using AI to sift through data from telescopes like the Green Bank Observatory. Meanwhile, astronomers are eyeing exoplanet atmospheres for techno-signatures, like industrial pollutants or artificial light. You're part of a generation with tools that can detect a city's glow on a planet light years away. Yet, the silence persists, making you wonder if we're misinterpreting the signs or if aliens are just really good at covering their tracks. Here's a light-hearted jab to keep things fun. Maybe aliens built their megastructures, but they're in stealth mode. Imagine a Dyson sphere with a cosmic cloaking device, like a galactic version of out-of-office mode. Sorry, humans, we're not taking calls right now. It's a playful thought, but it highlights a serious point. Advanced civilizations might not want to be found. They could be hiding their tech, using energy sources we don't understand, or living in ways that don't require massive, visible structures. The idea of cosmic engineering stretches your imagination. Picture a civilization redirecting a black hole's energy to power interstellar ships, or weaving a network of wormholes for instant travel. These aren't just structures. They're feats that reshape reality itself. But finding them is tough. Our telescopes are designed to spot natural phenomena. Stars, planets, supernovae, not artificial constructs. If aliens use tech that mimics nature, like bioengineered planets or subtle energy signatures, we might be staring right at them without knowing. The silence could mean we're not looking for the right clues. This search for techno-signatures is a test of our creativity. You're part of a species that's only just begun to think big. Solar farms, fusion reactors, maybe one day a Dyson swarm, but aliens could be light years ahead, using tech that feels like magic to us. The Great Filter might explain why we don't see them, or maybe we need to look beyond physical structures to subtler signs. Changes in a star's spectrum, gravitational anomalies, or even coded signals in cosmic noise. So, what's your take? What kind of alien tech should we be searching for? Drop your ideas in the comments, and let's keep hunting for the universe's hidden architects. You're floating in a sea of stars. But what if the aliens we're searching for aren't even in our universe? The multiverse theory suggests our cosmos might be one of countless realities, each with its own rules, stars, and maybe life. If intelligent civilizations exist in parallel universes, the silence of our universe might not mean we're alone. It could mean we're looking in the wrong reality. Let's dive into this mind-bending idea, explore the wild possibilities of a multiverse, and ask, could the answer to the Fermi Paradox lie beyond our cosmic borders? Picture yourself standing at the edge of reality, where the fabric of space-time ripples like a shimmering curtain. Beyond it, you sense other universes, some with stars like ours, others with physics so alien they defy comprehension. The air feels charged, as if the boundaries of existence are whispering secrets. The multiverse isn't just sci-fi. It's a serious hypothesis rooted in theories like string theory and cosmic inflation. These suggest our universe is one bubble in a vast cosmic foam, each bubble a separate reality. You feel a thrill, imagining aliens thriving in a universe next door, oblivious to our lonely search. Let's ground this in history. In the 1980s, physicist Alan Guth proposed cosmic inflation, a theory that our universe expanded rapidly after the Big Bang. This idea opened the door to the multiverse, suggesting that other universes might have formed alongside ours, each with different physical constants. Imagine Guth scribbling equations, his mind racing with the possibility that our reality is just one of many. His work reshaped cosmology, making you wonder if the silence we hear is because we're tuned to a single cosmic channel in a multiverse of possibilities. Here's a quirky detail to spark a grin. Some physicists speculate that a multiverse could include universes where the laws of physics allow for impossible life, like beings made of pure energy or living inside black holes. It's like imagining a universe where gravity works backward and aliens throw parties on the ceilings of stars. This wild idea stretches your mind, suggesting that life might not just be different, but fundamentally unrecognizable in another reality. Now, let's stir a scholarly debate. Does the multiverse solve the Fermi Paradox? Or is it an untestable cop-out? Some argue it's a tidy explanation. If aliens are in other universes, we'd never hear from them, neatly explaining the silence. Others say it's a dodge, a hypothesis we can't prove because we're stuck in our own cosmic bubble. You feel the tension of this debate, like trying to solve a puzzle with pieces you can't see. If the multiverse is real, our search for aliens might be like shouting across an infinite void, hoping for an echo from a reality we'll never reach. The sensory details pull you in. Imagine sitting at a computer, analyzing data from particle colliders like the Large Hadron Collider, searching for hints of extra dimensions. The room hums with the buzz of machinery, your eyes locked on graphs that might reveal a crack in reality. It's a quiet, intense moment, but the stakes are cosmic. You're not just hunting for particles, but for clues to other universes. The multiverse feels both tantalizingly close and impossibly far, a paradox that mirrors the silence we're trying to understand. Let's add a modern twist. In 2025, experiments in quantum physics and cosmology are pushing the boundaries of what we believe is possible. Social media buzzes with posts about multiverse discoveries, often hyped beyond the science. Yet, real experiments, like those probing quantum entanglement or cosmic microwave background radiation, are testing ideas that could hint at other realities. You're part of a generation that might glimpse these truths. But the multiverse remains elusive, a concept that's more philosophy than hard data. It's a reminder that our tools, as advanced as they are, might not yet be up to the task. Here's a light-hearted jab to keep things lively. Maybe aliens in another universe got our signals, but can't reply because their physics uses a different Wi-Fi protocol. Imagine them frustrated, trying to send us a message through a wormhole only to get a connection failed error. It's a fun thought, but it underscores a serious point. If the multiverse is real, communication across realities might be impossible. Our universe's silence could be a matter of isolation, not absence. The multiverse hypothesis reshapes the Fermi Paradox. If other universes exist, they could be teeming with life. Civilizations building Dyson spheres, exploring galaxies, or even transcending physical form. But we'd never know. Trapped in our own cosmic bubble. Picture a universe where time flows backward, or where life evolves in seconds rather than billions of years. You can almost see these alien worlds, vibrant and strange, yet forever out of reach. The silence might not mean we're alone, but that we're in the wrong neighborhood of reality. This idea challenges you to think beyond the stars. The multiverse isn't just a scientific theory, it's a philosophical leap, forcing you to question what existence means. Are we alone because our universe is unique? Or because we haven't found the cosmic door to other realities? For now, we keep searching, building telescopes, smashing particles, and dreaming of what lies beyond. You're part of this quest, a species daring to imagine the unimaginable. So, what's your take? If aliens are in another universe, how should we try to find them? Drop your wildest ideas in the comments and let's explore the multiverse together. You're lying on a grassy hill, staring up at a sky ablaze with stars, each one a silent question mark in the cosmic void. The universe's silence has led us through a journey of radio waves, strange life, great filters, and even other realities. But now it's time to turn inward. What does this quiet cosmos mean for humanity? Are we alone, or is our search for extraterrestrial life really a quest to understand ourselves? Let's wrap up this galactic adventure with a deep reflection on our place in the universe and why we keep looking up, no matter how silent the stars remain. Feel the cool grass beneath you, the faint chirp of crickets blending with the vastness above. The night sky isn't just a view, it's a challenge, a mirror reflecting your curiosity and fears. The Fermi Paradox, with its nagging question of where is everybody, isn't just about aliens. It's about humanity's relentless need to explore, to connect, to find meaning in a universe that doesn't owe us answers. You've journeyed through theories, radio signals, alien megastructures, multiverses, but the silence persists, like a song with no melody. Yet, that silence drives you to ask, what does it mean to be human in a cosmos that feels so empty? Let's anchor this in history. In 1990, the Voyager 1 spacecraft, drifting billions of miles from Earth, turned its camera back toward our planet and snapped a photo. That image, dubbed the pale blue dot by Carl Sagan, showed Earth as a tiny speck in a vast cosmic sea. Sagan's words hit hard. Our world, with all its triumphs and tragedies, is just a mote of dust suspended in a sunbeam. You feel the weight of that perspective. A humbling reminder that our search for aliens is also a search for our own significance in an unimaginably large universe. Here's a quirky tidbit to lighten the mood. In 1977, when NASA launched the Voyager Golden Records, they included a recording of a human heartbeat. Imagine aliens finding that record, hearing the steady thump-thump of a heart, and wondering what kind of creature feels so much it sends its pulse into space. It's a small, poetic act, but it captures why we search, not just for aliens, but for a connection that says we're not alone in feeling this way. Now, let's spark a scholarly debate. Is the search for extraterrestrial life driven by science or by our need for meaning? Some argue it's pure curiosity, fueled by data and telescopes. A quest to test the limits of biology and physics. Others say it's existential, a way to answer whether humanity is special or just one note in a cosmic symphony. You feel the pull of both sides. Science pushes you to scan the skies, but your heart wonders what it would mean to find someone, or no one, out there. Are we searching for aliens? Or for a mirror to reflect our own existence? The sensory details ground you. Imagine standing in an observatory, the dome creaking open to reveal a sky bursting with stars. The air smells faintly of metal and electronics, and your breath catches as you watch a telescope pivot toward a distant galaxy. Each moment of this search feels like a conversation with the universe, even if it hasn't answered back. The silence isn't empty. It's pregnant with possibility, urging you to keep asking, keep dreaming, keep reaching. Let's add a modern twist. In 2025, space exploration is hotter than ever. Private companies launch rockets weekly, and social media buzzes with debates about colonizing Mars or detecting biosignatures on distant exoplanets. You're part of a generation that's not just looking up, but planning to go out there. Maybe to the moon, Mars, or beyond. Yet, the silence of the universe looms large, a reminder that our tech, our dreams, and our memes about alien TikToks are all part of a bigger question. What's our role in this vast story? Here's a lighthearted jab to keep things fun. Maybe the universe is silent because aliens saw our internet and decided we're not ready for cosmic group chats. Imagine them scrolling through our posts, shaking their heads, and muttering, "These humans need to chill before we invite them to the galactic party." It's a playful thought, but it hides a truth. Our search for aliens is also a reflection of our flaws and hopes. We're messy, curious, and stubborn, refusing to let the silence stop us. The silence of the universe is a call to action. It pushes you to keep exploring, not just with telescopes, but with ideas, questions, and imagination. Picture a future where humanity builds its own megastructures, sends probes to distant stars, or even cracks the code of the multiverse. You're part of that future, a species that dares to ask big questions despite the odds. The Fermi Paradox isn't a dead end. It's a spark, igniting curiosity that's carried us from campfires to spacecraft. Maybe we'll find aliens tomorrow. Or maybe the search itself is the point, teaching us to grow, to unite, to keep looking up. As you lie on that hill, the stars above feel like old friends, silent but present. The universe doesn't owe you answers, but it offers something better. A chance to wonder, to dream, to create meaning. Whether we're alone or one of many, your curiosity is what keeps this journey alive. So, what's your final thought on the silence? Are we alone or just not listening right? Drop it in the comments, and let's keep this cosmic conversation going. The universe is quiet, but our voices don't have to be.